Okay, here are solutions to homework set number 1 for ECE 341, random processes. The first problem is a tree diagram. If I have two teams, A and B, playing a game, and it's the best of 5, meaning first one to win 3 games, and B starts with 1 point, meaning odds, come up with a tree diagram for who's going to win. So if I start out, I just have, this is A minus B, not really sure it's relevant, but if I start out right here, it's 0 and 1, B's won a game. Either B wins or A wins. If B wins, you're at 0 and 2. If B wins again, I'm at 0 and 3. As soon as you get to 3, the match is over. So again, either B wins or A wins. Either B wins or A wins, B wins or A wins. As soon as anybody gets to 3, the match is over. So that'd be your tree diagram. Problem 2 is enumeration. If I roll a 4-sided die and a 6-sided die, and the smaller the two numbers is my total, is my score, calculate the probability of scoring 1 point, 2 points, 3 points, and so on. Well, this is enumeration. So if I have a 4-sided die, 6-sided die, the matrix inside here are all combinations. So we could roll 1 and a 1, 1 and a 2, 1 and a 3, and so on. The numbers in bold are the minimum of the two. So just by counting, the probability of getting a 1 would be add up all the 1s. There's 9 of them, 24 scores, so that gives you 9/24ths chance of getting a 1. There are 7 2s, so the chance of scoring 2 points is 7 in 24. There are 5 3s, so the probability of getting 3 is 5 in 24. 4 is 3 in 24. No chance of getting a 5, no chance of getting a 6. So that's the enumeration. If you just have a small number of possibilities, enumeration works really well. Plus it's exact. Problem 3 is a conditional probability. Suppose I have a game. A rolls a 4-sided die, 6-sided die, takes the smaller of the two numbers, meaning problem number 2. B rolls a 6-sided die and subtracts 1. If A wins on ties, what's the probability that A is going to win? Well, problem 3 is a conditional probability, kind of leading up to 4. What's the probability that A wins given that B scores a 3? Meaning B rolled a 4. So for A to win, A has to score 3 points or 4 points. And if we go back to this table, I can just add them all up. There are 2, 4, 6, 8. 8 3s and 4s. So the probability is 8 in 24. Problem 4 is the one that leads into, what's the probability that A is going to win any given game? Well, that's actually kind of hard because I now have 6 times 6 times 4 possibilities. Enumeration doesn't work real well, but I can split it up into a conditional probability. What's the probability that A wins given that B scored 0 points times the probability B scored 0 points, 1 point, 2 points, 3 points, and so on? Well, if B scores 0 points and A wins on ties, A always wins. Well, if B scores 0 points, A is always going to win. If B scores 1 point, A will always win. If B scores 2 points, that's the number of 2s, 3s, 4s, which would be 15/24ths. If B scores 3 points, that'd be the number of 3s and 4s, 8/24ths, 4/24ths, and so on. So the probability that A is going to win is going to be the probability that A wins given that B scored 0 points times the probability that B scored 0 points, plus the probability that A wins given that B scored 1 point times the probability that B scored 1 point, 2 points, 3 points, 4 points, 5 points, 6 points. Add them all up, I get 51%. So there's a 51% chance that A is going to win any given game. That's what conditional probabilities do. They let you take a harder problem and split it up into smaller manageable problems. Problem 5 is enumeration and Farkle. Use MATLAB, go through every possibility of rolling 6 6-sided dice and count. How many times do you get 5 of a kind? How many times do you get 2 triples? So here's what the code looks like. I'm going to go through every possibility. That's nested for loops. And then at any given time, this is my die roll, D1 through D6. I will then count how many 1s I have, how many 2s, how many 3s. That's this section of code. Then sort in descending order, so the highest frequency appears in the first spot. If the highest frequency is a 5, I have a 5 of a kind. If the highest frequency is a 3, and the next higher frequency is also a 3, I've got 2 triples. And then just display at the end, how many 5 of a kinds did I get, how many 2 triples, divided by the total number of combinations, which is 6 to the 6th power. And what you wind up with is the probability of 5 of a kind is 0.0038. Probability of 2 triples is 0.0064. Now remember these two numbers because we're going to see those in the next homework set. Kind of calculate those odds using combinatorics. 4-card poker. Problems 7 and 8 are similar, just with a 4-card poker game where you deal out 4 cards. The question is, what's the probability of getting a 2-pair in 4-card poker or a single pair? Well, again, with enumeration, it's the same as before. Here the trick is the first card is anything in the deck, cards number 1 through 52. The second card, I've got to go up by 1. So if the first card's the ace of spades, the second card can't also be the ace of spades. It'll be the next card up. C3 is the next card up. C4 is the next card up. So my first hand is going to be the ace, 2, 3, 4 of spades. And so on for the entire deck. Again, nested for loops. Here's my hand. The value is take the hand mod 13. So it's going to go 1 through 13, ace through king, repeat, ace through king, ace through king. The suits, I don't care about in this problem. I'm going to count how many 1s, how many aces, 2s, 3s, 4s, and 5, sort in descending order. If the highest frequency is a 2, and the next highest frequency is also a 2, I've got 2 pair. If the highest frequency is a 2, and the next higher frequency is a 1, I have a single pair. Just count them all up. And when I'm done, display how many pairs, 2 pairs, and how many pairs I have. This is the total number of hands there are in 4-card poker. So if I do that, there's 2,808 different ways of getting 2 pair, or 1% chance. 82,386 pairs, 30% chance. And again, remember those two numbers because when we get to combinatorics, we'll see if we can calculate those two numbers. So that's homework set number 1 for ECE 341.